Hello superstars, welcome to the lesson. We are going to be working through exercise 9 and 10 from your textbooks, where we are going to be, what are we doing today, Claire? We're trying to find the size of these angles in the right angle triangles, and we know that we're going to be using our trig ratios in order to solve for x. Remember, in the previous lesson, we spoke about using the shift function on our calculator, and the correct wording we want to start using is arc sine, arc cos, arc tan. Right, that happens when I hit shift and then my trig function. All right, but let's not worry too much about that. Let's just start doing some mathematics, which makes me excited. If we start off with question 1, we know that labeling our triangle sides is so important, right? So that we can determine which trigonometric function we are going to use. If we look in question 1, the adjacent side is 14, the hypotenuse is 17, this length is our opposite length, right? Remember, we're always working from the reference angle to find these sides. So what ratio do I form? Which trig function do I get? Adjacent over hypotenuse. We know that that is cosine. Right, cos of your angle, cos of x in this case, is equal to adjacent over hypotenuse. All right, now we need to solve for x, where x is an angle. So what you do is, on your calculator, you hit shift, you press cos, and this is what pops up, right? It looks like cos to the -1. Remember that the correct wording, or the correct way of me saying this, is arc cosine or arc cos, right? But let's not worry too much about that. We've hit shift cos. We then punch 14 over 17 into our calculator. Let me just remind you how we do this. Right, so we're going to press shift, and then we're going to press our function, right? We decided that we're going to use cos since we had the adjacent side and the hypotenuse. Then we type in the fraction, 14 over 17, our ratio, and we get that the angle is 34,56. It's easy as that. Awesome. So we see then that in question 1, if we round off x to 2 decimal places, x is equal to 34,56 degrees. Amazing. And it's really as easy as that. Okay, let's get stuck in. Let's have a look at question 2. All right, so in question 2, from the reference angle, they've given me the opposite length. They've given me the adjacent length. There's my hypotenuse. So which trig ratio do I form when I have opposite and adjacent? We form tan, right? So tan of x, the reference angle here is x. Tan of x is opposite 4 over adjacent 6. So therefore arctan, now when I say arctan, I'm pressing shift tan on my calculator. So arctan, shift tan 4 over 6, close my brackets. Here x is going to be equal to 33,69 degrees. All right, and that's all we need to do. That's my final answer. This is easy, right? I think so. Let's have a look at number 3. From the reference angle, they've given me the opposite length, the hypotenuse is 13, the adjacent side, they haven't given me information about, but that's fine. I've got 2 out of 3 sides, that's perfect. So then I go, all right, if they've given me opposite and hypotenuse, which trig function do we form, grade 10s? Good, we know that that's going to be sine. So sine of x is equal to 8 opposite over 13, the hypotenuse. So therefore arc sine, so shift sine 8 over 13, let's find out what the size of that angle is. So arc sine 8 over 13, and my angle is 37,98 degrees. Okay, right, whoa, we are cruising. Cool, let's have a look at question 4. From the reference angle, let's get a label in. 13 is adjacent, 8 is opposite. I don't know anything about the hypotenuse, but we cool. Opposite over adjacent. What do I get, sine, cos, or tan? And you're all screaming, it's tan, Claire. And I'm going, yes, you are right. That tan of x is equal to 8 opposites over the adjacent side, 13. So therefore, arctan, shift tan, 8 over 13, arctan 8 over 13 will give me the size of the angle, and that works out to 31,61 degrees. Oh, amazing. All right. I'm going to scooch up to the top of the page here. All right. Let's have a look at question 5. So from here, see, I mean, this is like so easy, right? Really not too bad. So from the reference angle, they've given me opposites and the hypotenuse. So now you know, oh, that's sine. Okay, cool. Opposite over hypotenuse is how we get sine of x. So sine of x is 15 over 18. So arc sine, so me pressing shift on my calculator, then sine, I get that on the calculator. I fill in the fraction, 15 over 18, and what do we get as our angle? 56,44 degrees. 56,44 degrees. All right, good job. Well done, everyone. How's number 6 looking? All right, from the reference angle, adjacent, hypotenuse, that's cos of x is adjacent 7 over the hypotenuse 12. So arc cosine, when this happens, right, shift cos 7 over 12, we get that x is equal to, let's see what we get, 7 over 12, it's 54,31 degrees. Nice. Okay. Oh, we've got 3 left. Oh, my word. Hasn't this exercise just gone so quickly? Trig is just the best section. I love it. Let's see what yellow looks like. 7. Yeah, I like this yellow. Okay. From the reference angle, let's get a label in. Hypotenuse, opposite, adjacent. All right, so they've given me the opposite side and the hypotenuse. So opposite over hypotenuse, that's sine. So sine of x is 12 over 13. So therefore, arc sine 12 over 13 will give me, or solve the angle. So I press shift, sine 12 over 13 on my calculator, and I get an angle of 67,38 degrees. Awesome. 2 to go. Okay, let's have a look at number 8. I feel like this is not going to get any more difficult, right? What have they given us? The opposite, the adjacent side. So really, this first step of labeling your sides, which is pretty easy to do, is so important to this, right? Because then you know, am I going to use sine, cos, or tan? Opposite over adjacent. So this question, we're going to be using tan. So tan of x is equal to opposite 18 over adjacent 25. So arctan 18 over 25. That will let me solve for x. So x is equal to, so I press shift, tan 18 over 25 on my calculator, and my angle is 35,75 degrees. Awesome. Oh, and look at that. We're on the last question because we are so smart. All right, let's get a label. Let's get a label in. I should make a song. All right, so let's see what we got. We've got the adjacent and the hypotenuse. Cos, nice. Cosine x is equal to 10 over 14. So for number 9, cosine x, cos x is equal to 10 over 14. So x is equal to arc cosine 10 over 14. Therefore, what's x equal to? So I'm going shift on my calculator, cos arc cosine 10 over 14. And my angle is 44,42. 44, rounded off to 2 decimals, 42 degrees. Oh my goodness, we just cruised through this exercise. Well done. Okay, let's have a look at exercise 10. Awesome, so let's get going with exercise 10. Okay, let's have a look at this first triangle that they gave us. So we're doing the exact same as in the previous exercise, right? We're just also solving for another variable. We're solving for x and or y. Okay, so have a look at question 1. Some of you might be tempted to find x. You might just want to start off by working in this triangle in the front. And you're going to go, oh, this is no problem because there's my adjacent, there's our hypotenuse, so cos of x is 14 over 25, boom, found x. But you would be incorrect because this triangle does not contain what? A right angle. I need a 90 degree in order to form my different trig functions, right? So you cannot work in that front triangle. You need to look at, well, let's see which triangles we are going to work in then. We're going to be working in the big right angle triangle, ABC. Okay, and then you're going to be working in this smaller right angle triangle over here, ADC. Okay, so those are the 2 triangles that are going to be working in, not the little one in front, but the big right angle triangle, ABC, and the smaller triangle in green, ADC. Okay, so now that that's out of the way, let's get cracking. So what should we find first? So if this is our reference angle over there, okay, I have the opposite length and I have the hypotenuse. So from the reference angle, I'm looking now in the big triangle, grade 10s. 18 is the opposite side, AC, and the hypotenuse is AB. So for question 1, to find the size of x, we're going to say that sine of x. So I'm actually going to write here, we're in triangle ABC. All right, where sine of x will be opposite over hypotenuse, 18 over 25. So arc sine x, sorry, not arc sine x, but arc sine 18 over 25, that will help us solve for x. So x is going to be, so I'll go shift sine 18 over 25, that's 46,0. 46,05 degrees. Cool. Okay, so I've found x. Now I need to find y. So in this smaller triangle, so now we're in triangle ADC. In the smaller triangle, you have the opposite side, but you don't know the adjacent length and you don't know the hypotenuse. Okay, so now we feel like, oh, I'm stuck. But then I saw that they gave us this length BD. And I think to myself, okay, so surely this is going to be significant to something. And what we can do is we can determine this entire length BC, right? Which is the bottom length of the big right angle triangle. We're going to work out what this full length is. If I subtract 14, the leftover amount will be the length DC. Then I'll have an opposite and adjacent side, and that will create tan, and then I can solve for y. Okay, so I need to figure out this length BC. So we're going to practice a little bit of Pythagoras here, grade 10s. So I'm actually going to get rid of this for now because I'm still working in that big triangle ABC. So Pythagoras, your theorem of Pythagoras is that the hypotenuse squared is equal to the side squared, so I'm looking for BC, plus your other side squared, right? That's Pythagoras. So if I did 25 squared minus 18 squared, that would be BC squared. So 25 squared minus 18 squared is 301. So 301 is equal to BC squared. But remember that you're not looking for BC squared, you're looking for BC. So now we're going to square root both sides. So BC is equal to the square root of 301, sorry. So that's 17,35 as a decimal. 17,35. So therefore, what will DC be equal to? So DC now is this little portion over there. So all of this length is 17,35. We know that BD is 14, so we're just going to subtract 14 from that. And your answer will be 3,35. All right, so the length of DC is 3,35. Right, so now we can move into triangle ADC, where I'll say, okay, so to find out the size of y, I have the opposite length. I've now determined my adjacent side. So opposite over adjacent, we get tan. So tan of y is 18 over 3,35, right? That length we just determined, DC. So y will be arctan 18 over 3,35. So therefore, let's see. Y is going to be equal to 79,46 degrees. All right, good. So it looks a little bit intimidating at first, hey? And you go through and you're like, actually, this ain't so bad. All right, let's have a look at question 2. So in question 2, again, we've got a couple of triangles, eh? We've got this little right angle triangle over here that contains the y. Remember, because of supplementary angles, that angle there is obviously also 90 degrees. Then we've got this right angle triangle over here, right, that contains the x, so the triangle ADB. But don't forget, you can actually also look at this whole triangle in its entirety, right? We can look at the big right angle triangle ABC. All right, so we might have to use all three of these triangles in this question. Let's have a look what we need to find. Right, so I think let's start off by finding that angle X, because I can work in the big right angle triangle. So I'm going to work in triangle ABC. All right, so from the angle, I have the opposite length 5 and the adjacent length 12. So in this big triangle here, there's your 90. So that's the hypotenuse, right? So we have opposite over adjacent. Opposite over adjacent, we for tan. So tan of x is equal to 5 over 12. So arctan 5 over 12. Remember, this is how we're going to find the size of our angle. If we punch it into a calculator, remember, you go shift tan 5 over 12. We get that x is equal to 22,62 degrees. Now, if I focus on the green triangle now, all right, so on this one, okay, there's the 90. We just figured out that this angle is 22,62 degrees. So I can use some angles of a triangle to get that angle over there. Then, knowing that all of that angle is 90 degrees, right, at CAB. We know the angle at CAB is 90 degrees, so we can just say 90 minus that angle over here, right? 90 minus that will give you y, because complementary angles add up to 90 degrees. So actually, this question's not too bad in the end. So now I'm going to work in triangle. What's that triangle called? So now we're going to be in triangle ADB. All right, so in triangle ADB, the angle DAB is equal to 180 minus 90 minus 22,62, right, because of some angles of a triangle. So that is equal to 67,38 degrees. So angle DAB, angle DAB, is equal to 67,38 degrees. So to solve for y, you're going to go, so therefore y is equal to 90 minus 63,38. I should actually put my reasons here. So this reason here was some angles of a triangle, right? This reason here is complementary angles. Okay, complementary angles add up to 90. So if I now go 90 minus 67,38, that will be the size of y, and that's actually the same size as x, which makes a lot of sense. Okay, so we found x and y in our question 2. Cool, so that was question 2. Not so bad in the end, actually. So let's have a look at question 3. It looks quite similar to question 2. Okay, I'm just going to get rid of all of this. All right, so again, we've got a big triangle. We've got the big right angle triangle, ACB. We've got that x in the similar position as in question 2. The only thing that's different here is now where y is sitting. So y is now in this bottom corner. So we can't just do the complementary angles like we did in the previous question. All right. So these are the 3 different triangles that we can work in now. All right. But we are going to start off in that big right angle triangle first to solve x. All right, so I'm just making some space for myself. Okay, so question 3, let's have a go. All right, so we're going to start off in triangle ABC. We're going to start off in the big right angle triangle first. So from x, you have, from the reference angle, they gave you opposites and adjacent. Right, so same as in the previous question. To solve for x, it's going to be arctan 4/7. Remember that tan is opposite over adjacent, looking in the big triangle. So straight away, I'm now just going to go arctan 4/7, and we get that x is equal to 29,74 degrees, rounded off to 2 decimals. Okay. So I'm going to write that here, 29,74 degrees. Actually, this one is easier than the previous question. And why is that? Because I can actually now just look at this full right angle triangle. I don't have to worry about the other triangles because I can just do some angles of a triangle now in this big one. Because I've got 90, I've got that vertex angle, and now I can just do some angles to get this bottom angle. So actually this is easier than the previous question. That's awesome. All right, so to solve for y, you're going to go 180 minus 90 minus 29,74 degrees. Right, your reason is some angles of a triangle. So y will be equal to, let's see what that is. Y is going to be equal to 60,74 26 degrees. Okay, that's awesome. So actually question 3 in the end, pretty easy. Okay, let's get into question 4. Let's see what they throw at us now. So we've got a reference angle over there in a right angle triangle. So we're good. Triangle ABD. X, that's actually what we're trying to find. So what we're going to do is we're going to start off. We're going to start off in this triangle here. All right. And we're going to find out the length of AD. Then I'm going to move into the triangle next to it. Okay. So we can't solve for X straight off the bat. We need to first work in that triangle on the left. So in triangle ABD, we get, okay, so AD, this is the length that we're looking for, right? Because it's moving into this triangle where X is. So from the reference angle, AD is opposite, 14 is the hypotenuse. So opposite over hypotenuse makes your sine, right? So sine of 40 is equal to AD opposite over the hypotenuse. So 14 times sine of 40 will be equal to AD. So let's see what that is. 14 times sine of 40, that's going to be, well, it's 8,999. So if we round it off, it's going to just be 9. All right, so now in this triangle, we figured out that this length AD is 9. So now I can find X. So from the right angle, the 9 is the hypotenuse, right? So this is going to be adjacent over hypotenuse. So that's cosine X. So adjacent is 8. The hypotenuse you've now figured out is 9. All right. So I'm just going to scooch this up. If I say in triangle, so now we've moved into triangle ADC. All right, so what did we say? We said cosine X, okay, is equal to 8 over 9. You can actually jump straight away to this point now. We go arc cosine, right? Because we know that that's when we're finding the size of an angle. So I press shift, cos 8 over 9, and we get that that angle then is equal to 27,27 degrees. Awesome. Just 2 more questions left. Okay, let's have a look. What does 5 and 6 have in store for us? Okay, so let's see. What does this bad boy say? All right, so in question 5, they give us all these parallel lines. Okay, so we've got a set of parallel lines here. Okay, so do you see the Z shape, the alternate angles? That angle would be equal to that angle using alternate angles. So we know that angle DAC is also going to be equal to 90. Then they give us a second set of parallel lines over here. And you see you get that Z shape again. So this angle X, right? Those 2 angles are also going to be the same size. Both of those angles are going to be X. Okay. So let me just tidy this up a bit because we can't see everything. So just to summarize, this angle here is X through alternate angles, and this angle here is 90 through alternate angles. So we want to start off in this triangle because we have these 2 given lengths and then the angle that we need to find. I don't want to start off in this triangle. I don't have enough information. All right, so let's start off in triangle ABC. So in triangle ABC, all right, what's happening? From X, my reference angle, this would be opposite hypotenuse. This length 14 is the adjacent side. So they've given me adjacent and hypotenuse. So adjacent over hypotenuse, we create cosine. All right. So cosine X would be 14 over 18. So X would be arc cosine. Right. Remember, you're going shift cos 14/18. Right, so let's see what that simplifies to. That's going to be 38,94 degrees. All right, so that angle X is equal to 34,94. So like I said, using the alternate angles now, you know that this bottom angle is also going to be 38,94, right? That's what you just solved X to be over there. So now working in this triangle, you can just do sum angles of a triangle to find Y. So Y is going to be equal to 180 minus 90 minus 38,94. All right, I should have written down, I should have written this down first. I should have first said that angle angle DCA is equal to 38,94 because alt angles equal. All right, so I should have started off with that first. Now I say to solve for Y, I'm going to use sum angles of a triangle. So Y is equal to 180 minus 90 minus 38.94, which is 51,06 degrees. Okay, nice. So that's for 5. We've solved for X and we've solved for Y. Okay. So I'm just going to clear up space over here. So sorry about question 6 being above question 5, but I'm sure you will forgive me. Okay. All right, last one. Good job, grade 10s. So let's have a look in this question. So they given us this really big triangle, right? We can see that the lengths of the sides are the same, right? So what type of triangle is this actually, the big one? Okay, this is an isosceles triangle, right? The adjacent sides are equal in length. So we also know that the base angles in an isosceles triangle are the same. So this, if that is X, that angle over there will also be X because of base angles, isosceles triangle, or angles opposite equal sides. This length we know is going to be 90 because of supplementary angles. And they show you that the bottom length is 12, but that line AD, we call it perpendicular bisector, and it's going to cut that length equally in half. So BD and DC will be the same length. They're both going to be 6. All right, so let's start off in that triangle on the left. We're going to start off in triangle ABD, all right? So from X, you have your adjacent and your hypotenuse, right? Your lengths that have been given. So X will be arc cosine 6/8. So remember, you're going shift cos 6/8, shift cos 6/8. What do we get? 41,41 degrees, right? So I can then say, since we know that this is an isosceles triangle, that angle ACD is equal to 41,41 degrees. Angles opposite equal sides. Okay, so angle opposite equal sides, that's the more formal way of saying base angles isosceles triangle. The angles are equal opposite lengths, which are equal. Okay. So now I can move into triangle ADC, because now in triangle ADC, you've got this scenario, right? You know that that is 90. We know that this is 41,41 degrees. You just have to find Y. So again, you can just use sum angles of a triangle, right? Using this information over there. So actually, I should write that not where it is. You should write that over there. Okay, so I'm just going to move it. If yours is down already, no worries. So now I'm going to say angle DCA is equal to 41,41. My reason was angles opposites equal side, angles opposites equal sides. All right, so y is going to be 180 minus 90 minus 41,41 degrees. Reason, some angles of a triangle. Cool, so let's get it. So y is going to be equal to 48,59 degrees. Hooray, well done. These were two pretty, that's meant to be a star. These were two pretty long exercises, but you did it. Congratulations. Good job, everyone, and I hope you enjoyed the lesson.